And we are live. Welcome for this live stream. Today we are going to do a coding tutorial. We are going to code a prediction market. So let me show you how does it look like. So basically this is going to be a decentralized app that allows us to bet who is going to win the next US presidential election, Trump versus Kamala. And so people will be able to bet with Ether, and depending on who win at the end, they will make money or lose money. So it's similar to sport betting, for example, but it's not limited to sport, and this is completely decentralized, so we don't need any intermediary. So this is the app that we are going to do. So here you can see how many people betted Trump versus Kamala. Here you can bet either Trump or Kamala. You can see your bets, and at the end, once the election is finished, you can claim your gain here. So we are going to code this app with JavaScript, HTML, CSS. So this is going to be on the front end. This is going to be a web application. And on the blockchain, so we're going to use Ethereum as well as a programming language called Solidity. So that's the most popular language for program under Ethereum blockchain. This is what we call smart contract. And also on the front end, we will use a JavaScript library called Ethers to interact with the blockchain. So let's see how we can combine all this technology. All right, so everybody in the chat, hi everybody. So we have Kiri, Cave, we have THX. All right, and so for those who are new here, very briefly, before we get started, so check out my free career guide. It's going to explain everything that you need to learn to get started in blockchain. So basically the whole roadmap will be given to you, what to learn and how to get your first job in the space. This is completely free and it's going to save you so much time. eattheblocks.com/roadmap. Okay, so with this being said, let's get started for the smart contract. So here I've already have a skeleton code, but basically I started with a Next.js boilerplate, so you can get it like this: npx create next app, and this is going to give you some basic code. And so here I've already created some file. I'm going to explain what I've created. So here I just have some basic HTML and CSS. So since this is not a tutorial on HTML and CSS, we're not going to spend too much time on this, but basically let's see what we have now. So you can run npm run dev, and this is going to start the server. So here I need to install the dependency. Okay, so I'm going to do this now, npm install at the root of the project. Okay, and it's going to install everything that you have listed in your package.json. So here, bootstrap icon. This is a CSS framework to make it nice. Ethers, I mentioned it. This is the library to connect to the blockchain. Next.js, React. This is the framework that we use for the front end. React Chart.js. So this is a library so that we can get this nice chart that I showed you before. And yeah, so those are the most important libraries. So now if you run npm run dev, our server should work. Okay, so let me see, localhost 3000. Right, so here let me just have a little problem. So let's import our style sheet. Okay, so import styles from page module.css, and now okay, it should work. So bet prediction market bet on the US election. Okay, so we have a basic app, but before we go further with the front end, we need to work on the smart contract. So in order to work on the smart contract, you're going to need a framework called Foundry. I'm going to show you this. Okay. So this is a smart contract framework. This allows you to run tests on your smart contract, and with smart contract, tests are very, very important. So in the past, there were other framework like Truffle. If you've been in the space for a while, then we had Hat, and finally we had Foundry. So right now, Foundry is the most popular framework for smart contract. So it's very easy to install Foundry. You just follow the instruction here. Just copy paste this command in your terminal, and you're gonna get it. And after, it's going to give you access to a command called Forge. And Forge allow you to bootstrap a blockchain project locally. So how you do this, you do Forge init and then the name of the blockchain project. So in our case, we're just gonna call this blockchain. And also I'm gonna specify an option called no git, because basically we are already in a Git repo here. So we are in Next.js app, and by default Next.js already create a Git repo. You can see here a git ignore file. And Forge is going to refuse to create a project inside, because itself is going to create a Git repo. Okay, so sorry, readjust my mic here. And so we specify no git to say, hey, we don't want a Git repo. Okay, so here, just to help you understand how the layout of our project. So most of this, all of this, this is Next.js, right? And you see one folder here is blockchain. This is our Foundry project. So the Foundry project is inside Next.js, okay? So let's open this, and you will get it by running forge init blockchain, etc. Okay? So here the important folder is src, okay? Because this is the folder that where you will put your smart contract, and the other important folder is a test. This is where you will put your test. All right, so we're going to start with the smart contract, right? So let me delete this and let's start again. So prediction market.sol. So Solidity, this is the language that we will use for our smart contract. And the extension of Solidity is .sol. And so this is this program that will run on the blockchain. And in our application, this is where we will store the important data. Okay, so this will be the equivalent of our database and of our backend code. Okay, so the front end is just going to interact with this contract, but everything very important is going to be there. Okay, so let's see this. Let's see how we're gonna create this contract. So first we start with a pragma statement. Okay, pragma solidity 0.8.26. So this gives you the version of Solidity, so that if we try to compile this contract with another version, Solidity is going to complain. So this is to protect you. And after that, we're gonna define a smart contract with the contract keyword. And then we give the name of the smart contract, so prediction market. And everything that is inside the curly braces is inside the smart contract, and everything outside is not. All right, so now let's try to understand a little bit what we need to do. So we need a function for placing bet. Okay, first thing to do. So if you want to bet on Kamala or Trump, then you're going to use this function. Then we need a function to withdraw. So basically, once my mic arm is super annoying here. Sorry for the noise. Just it doesn't hold. All right, you good, Mike? Yeah, you're not gonna move anymore. Okay, thank you so much. All right. So another function to withdraw your money. So once the election is finished, then if you win, you want to withdraw. And finally, we want a function to report the result of the election. Okay, so that's going to be typically an admin that can call this function to tell who won, either Kamala or Trump. All right, so now we need to define a few data structure. Okay, so first we are going to use an enum. So an enum is a custom type, so meaning that this is a type that you can define yourself, where first you define the name of the enum and then the different options. Okay, so here we have two options, either Kamala or Trump. Okay, and we're going to use this enum in a couple of places. Then we're going to use another custom type called a struct. So struct is a little bit like an object, but contrary to JavaScript or Python, you will need to define the field of this type. So we call it result. This is the result of the election, and it's going to have two fields. First, the winner, okay, and then the loser. Okay, so here you have the type of the field, that's a side, and then you have the name of the field, winner, side, loser. Okay, so, and here it's interesting because in struct you can reference some enum that you defined before. So next we are going to create an instance of this result, because here we're just defining a variable type, but it's actually not stored anywhere. So in order to create an instance, so we define the type of the variable. Then public, this is a keyword that means that this variable can be read from outside of the blockchain. In most cases, you want public variable. It's very rare that you want private variable. And finally, you give the variable name, so result. So here, this is result with a lowercase, and here this is result with an uppercase. So it doesn't mean the same thing. This result refer to the struct, and this result refer to this is the name of the variable. Okay. And within our function, we will be able to read or modify this result. All right, so after that, we will need a Boolean value. So it can be either true or false. We'll make it public also. And this is a Boolean value to tell you if the election is finished. All right. So after that, we're gonna have what's called a mapping. So a mapping is like a key value store. Okay, so in JavaScript, for example, you can define key value store like this with, for example, you can have a key, you can have a string as a key, like key 1, for example, and after you can have a number, key 2, etc. So this is what you would do in JavaScript. And in Solidity, we can do something similar, but with a mapping. But we need to define the type of the keys and the values. So here, we're going to define a mapping where the key are of type side. So this is the enum side. And after, the value are going to be of type uint. Okay, and bets per candidate. So we're gonna have two records. Okay, we're gonna have basically one record for Kamala. Okay, and here we're gonna have a number. So that's the number of ether that was bet on Kamala, and then we're gonna have another one for Trump. Okay, so maybe 2000, something like this. Right, so every time someone bet, we are going to update this. And we finish this declaration by a semicolon, like all declaration in Solidity. All right, after that, we are going to create another mapping. It's going to be slightly more complex. So the key is going to be the address. So type address, this is a very useful type in Solidity. This is to represent address, and an address on Ethereum is a little bit like a bank account number. So it identifies your account. So people can have accounts. So you and me, we can generate an address with a wallet software. But smart contracts, so this is what we are creating. Basically, smart contracts also have an address. And here we will record the address of the gambler, basically. and it's going to map to another mapping. So it's possible to do this, to declare a mapping within a mapping. So how would that compare to JavaScript? Well, it's as if in JavaScript, let's say for the value here, let's say you have another object. So here, name and etc. Name. So this is how you would translate in JavaScript, something like this. So a mapping that's going to be side that maps to uint, so unside integer, basically a positive integer. And we're going to make this public. We're going to call this bets per gambler. Okay, so here we're going to have, let's say, an address like this, and it's going to map to a side. So for example, Kamala, and then the number of Ether that you've bet on Kamala, right? And a single address can actually bet on both sides. I mean, it's a bit stupid, but technically this is possible. So you would have two record like this, and then if you have, let's say now you have another address that bets, so it's gonna be something like another address like this, and then you're gonna have the other record inside like this. All right. So this is what we're gonna have in bets per gambler. Okay. So we've defined most of the data structure. We only have one left, so that's the address of the oracle. So the oracle, this is going to be a special address that has a special right in our smart contract, because it will be able to report the result of the election. So of course, this is very sensitive. This is going to be someone that we trust. It's possible to make it a little bit more decentralized by having this address be a smart contract itself. Okay, so the oracle can be a smart contract where you have a bunch of people who will vote to report the result of the election. That can give you a little bit more trust. So instead of just one person that report the result, you can have a bunch of people that vote in this other smart contract, and itself, this other smart contract we'll call our smart contract. But in our case, it's just going to be a simple address for when we're going to do the testing. We just want to keep it simple here, okay? So the next thing we're going to do is we need a constructor. So constructor, this is a special function that is called when you deploy the smart contract for the first time during the first deployment. And we use this to do some initialization. So here we want to initialize the oracle address. Okay, so we define a constructor and we give it an argument. So you need to define the type of the variable and the name of the variable, and after that we're going to instantiate our oracle. So we just do it like this. So we assign the value of underscore oracle to an oracle that is defined just above. So everything that you see defined here, this is going to be stored long-term on the blockchain. Okay, so now we have our initialization code ready. And next we need the function for placing bet. Okay, so for that we're going to use the special keyword function. And after that we give the name of the function bet. And after that we have parentheses. So you don't have to have arguments. You can have a function that doesn't take any argument, but here we will take some argument. So the type of the argument will be a side. Name of the argument is underscore side. Okay, and after that we need to some special keywords. So external, it means we can call this function from outside of the blockchain. It's possible to also have internal function that cannot be called from outside, but only from the smart contract. We're going to make it payable, meaning that we can send Ether to this function, because by default with Solidity, you cannot send Ether to a function. So if we just do a function like this, we cannot, and you try to send money to bet, it's not going to work. Okay, so we make it payable. And after that, we open the curly braces, and inside, this is the body of our function. And we need to do a check, okay, a safety check. And we can do this with a require statement. And a require statement is going to test a condition. And if this condition is true, it's going to just keep running the code. Otherwise, it's going to throw an error and your transaction is going to be interrupted. Every state change will be reverted. All right, so here we're going to check that the election is not finished. So election finished needs to be false. This is how you do a comparison with Solidity double equal. And if this statement is not true, we are going to provide an error message. So here, election is finished, so we cannot bet anymore. This is too late. Okay. After that, we are going to create. We're going to put a new record in bets per candidate in our mapping. Okay, so we reference it like this, and we specify a key with a square bracket, and inside here the key we're going to use is first the side. Okay, so here bets per candidate, this is defined here, and the key is side. And here we need to increment what is already inside. And how are we going to increment it? With MSG value. So in Solidity, we have some built-in variable like MSG value that gives you some information about the context. Here, MSG value will tell you how much Ether was sent to this function. And we don't, here, very important, we use the increment operator. Okay, so this means this is the equivalent of this. Okay, let me make it even more simple than this. Is as if you do this. Okay, so it's going to evaluate what is already in this record. It adds MSG value, and then it puts everything inside. It overrides everything that we have inside. But here, this is very important that we use the increment operator and not the equal operator, because in this case, we're just going to overwrite with the new value, but you're going to throw away all the contribution that happened before. Let's say I bet 1 Ether and then you bet 2 Ether. Well, instead of being 3, this will mean that only the last value is saved. So this is not what we want. We want the increment operator. And we also want to store how much was bet per gambler. So for that, we use the other mapping, bets per gambler. Okay, so here we have it. And now we use another built-in variable called msg.sender, and this will give you the address of the sender of the transaction. And how we are sure that this is correct? Well, you need to trust the cryptography of the blockchain, but basically without doing anything, we have this authentication system. We can trust that MSG sender is the real address that was used to sign this transaction. We don't need to do any other verification. This is provided to us, ready to use. So this is one of the huge benefits of Ethereum. Okay, and after we have a second key. Okay, so here we have the address. This is the first key, but the inner key is the side. So specify the other key like this with underscore side. Okay, and again, we use the increment operator, MSG value. And yes, and so now we have our bet function. Okay, so now what about when, let me see, I have a question here. Can you go in detail how the smart contract will work on the Tron network? So Tron is EVM based, meaning that this is based on Ethereum. So it's going to work exactly the same. Like you can copy paste this smart contract, deploy it on Tron, it's going to work exactly the same. So basically, this is also the benefit of learning Ethereum and Solidity, is that this is applicable to so many blockchains that are just copycat of Ethereum. So you can really leverage your knowledge a lot. So now we're going to create the withdraw function where we will withdraw our money if we win the bet. Okay, so we use the function keyword, then the name of the function is withdraw. Okay, so no argument this time. external, so we could call it from outside of the blockchain. Okay, and after we're gonna read the what is our bet. Okay, so we define a variable of type uint, so this is basically a positive integer. Gambler bet, okay, this is the name of our local variable. And by the way, when we define a variable here inside the body of function, this is not going to be stored long-term on the blockchain. This is just a local variable, and it just exists during the lifetime of a transaction, okay, which is very short. It's going to disappear after the transaction. So here we reference bets per gambler, and we want to read MSG sender, so this is the address of the sender of the transaction. And the second key is result winner. Okay, so let's go back to the beginning. So here result, this is a variable of type result that has two fields, winner and loser. Okay, so here we assume that the election is already finished and that the oracle already updated this variable, so we know who is the winner. Okay, and so we want to see how much we bet for this sender and for the winner. Okay, and of course there is no guarantee that we actually bet something. Maybe we got it wrong. So if we bet nothing, then here we are going to see 0. Otherwise, we're going to see how much we bet. So you might be confused because we never instantiated this entry before, okay? Like if we have 0, we never, means we never call the bet function with the side of the winner. But in Solidity, you can always read a mapping even for the record that do not exist. And what you will read is the default value, okay? So let me make it more clear because I'm sure this is very confusing. Let's say you're trying to read a record here for this mapping with an address that we never use this address for any record. So for an inexistent record, well, you can still, it's not going to give you an error. It's going to give you the default value of the value, which is 0 here. The default value of integer is 0, okay? So here, if we have 0, it means that we cannot withdraw anything, right? So we are going to require that the gambler bet is 0. In other words, we require that we made the right choice, okay? So you do not have any winning bet, okay? So this is the error message. And after that, we're also going to require that the election is finished. Okay. So true. Election not finished yet. Okay. And after that, we are going to calculate our gain. So how much money we made. Okay. So let's define another local variable. So first of all, we're going to get our money back. Okay, it makes sense that if you bet on something and you win, at least you should get, all the winner should get their money back. Plus, what's going to happen is that all the winner, they're going to share among themselves all the money of the loser. Okay, so we take all the money of the loser and we share it proportionally to the winner depending on their contribution. Okay, makes sense. So here basically it's going to be money plus money of loser time proportion of gambler. Okay, that's going to be like simplified is something like this. All right, so how about the money of the loser? Okay, so in order to do that, what we do is bets per candidate and we read result loser. Okay, the way we structure this smart contract makes it really easy to get this value, and then to get the proportion, what we do is gambler bet divided by bets per candidate, but this time we're going to read the total for the winner. Okay, result winner. All right, and now semicolon here. Okay, so now we have our gain, and next we need to update our internal state in the smart contracts, bets per gambler. So MSG sender side Kamala. So we put every side at 0. Okay, we reset everything. Bets per side. Because if we don't do this, if we don't reset this state, it means that you can call the withdrawal function as many times as you want. The required statement will pass, and basically you can hack the smart contract. So this is just super, super important. And then we are going to send the money to the gambler. So how are we going to do that? First of all, we cast MSG sender into a payable address. So there are two types of address. There's the simple address, and then there's address payable, and you can only send money to address payable. So in order to do that, to transform a normal address, which is MSG sender, to a payable one, you just use the payable key operator like this. Then to send money, you use the call function. And after we can specify the value that is sent, so this is the gain. And here, between parentheses, we're going to put an empty string. So this is actually what we call a low-level call. You can use this to call the function of other smart contracts. So if you have a function to call, this is where you're going to put the signature of the function. But in this case, we don't call any function, so this is empty. All we care about is this part where we actually send money, and we need to verify that the call was successful. So it's possible for a money transfer to fail if the recipient is a smart contract and is not equipped to receive Ether. There is a special way to create smart contracts so that they can receive Ether, and by default, a smart contract cannot receive Ether. We're not going to get into this because this is not directly relevant for today, but this is why we do our check. So in order to make sure that this was successful, we define a Boolean value because the call is going to return this, so true in case of success. Another variable that we don't care about. And we get the return value, and we gonna have another require statement, okay, where we make sure that the transfer was a success. All right, and after this is not the case, we have the error message, withdrawal failed. Okay. All right, and so we have the withdrawal function. So that was the hardest function that we will do in this smart contract. All right, so let me see a couple more questions here. What about the environment? Can Foundry be used? Yes, right now we are using Foundry, and just after we will create a test and we will run it in Foundry. We will also use the scripting function of Foundry. So yeah, I'm going to demo all of this. So someone asked, can I make this code available? So I plan to release a new offer to give you access to the source code of all my tutorial. I know I've been talking about it for a while now. A lot of people asking for it. So I will let you know once the offer is ready. Okay, so now we have the withdraw function. So now let's do the report function. So this is the function that is used by the Oracle to give the result of the election. Once the election is finished, a special address that we trust is going to tell us who won the election. Okay, so, and that's because the smart contract cannot interact directly with the outside world. We cannot do HTTP call in our smart contract. In Solidity, we cannot say, hey, let's hit some API that give us the result of the election. We cannot do this. a smart contract can only interact with what's inside the blockchain. So to get around this limitation, we do it the other way around. We send a transaction from the outside to the smart contract, and we in this transaction, it's going to contain the result of the election. Okay, so we do from the outside to the blockchain, but not the other way around. Okay, so function report, and it's going to take a couple of arguments. So first, who is the winner? Who is the loser? Okay, let's make it external so that we can call it from outside. And we need to require, so first of all, we need to make sure that the sender of this transaction is Oracle, okay? Otherwise, anybody can call this and put some fake results, so we don't want that. Only Oracle, this is the error message. And after that, we also need to make sure that the winner and the loser are different, okay? Because if the winner and loser are the same, it means that there is a mistake, okay? So the winner needs to be different from the loser, and the error message winner and loser cannot be the same, okay? Then let's update our result variable. So just as a reminder, the result variable here, this is a struct with two fields, winner and loser, okay? So here winner equal underscore winner and result loser equal underscore loser, okay? And last thing that we want is election finished equal true. And once this function has been called, then people can call the withdraw function, but not before. Okay, so now our smart contract is finished. So you see it's not very long, it's just 46 lines. In general, smart contracts are never very long, so it's not like JavaScript or Python where you can have like huge application with tens of thousands of lines of codes. In general, for Solidity, it's only maximum a few hundred lines of code, but we don't want to make it too complicated, because if it's too complicated, it's more likely that there will be some security vulnerability, and so we want to keep it simple. And also, there is a limit of 24 kilobytes for the code of each smart contract. So in any case, it's not even possible technically to do a very long smart contract, okay? So this is our smart contract, okay? So what do we need to do next? Can we jump directly to the front end? No, and I'm gonna tell you why. So the big problem that we have, okay, is that on the blockchain, smart contracts are very sensitive, okay? So if once you deploy smart contract, it's not possible to update the code. It's not like JavaScript or Python where you can just push some new code to your server and you do whatever you want. No, on the blockchain, you deploy smart contract, and that's it. The code can never change. This is actually the value proposition of the blockchain. This is immutable, okay? So this has some big advantages, but also a huge disadvantage, which is if there is a bug, you cannot fix the bug. And worst, you will see hacker drain the money of your smart contract live, and there's nothing you can do, absolutely nothing. So this is why it's extremely important to test your smart contract before deployment, okay? And in general, you're gonna spend more time testing your smart contract than writing the code of your smart contract. Let's say you have 100 line of code of smart contract code, maybe you're gonna have 200 or 300 line of code for test, okay? And it turns out with Foundry, the framework we're using, we can do test, okay? So for that, let's go back to the code. For that, we're gonna go in the test folder, and we're gonna create a file, predictionmarket.t.sol. Okay, so here we're gonna remove what I've already done. Okay, let me see. All right, we're gonna start from 0. So here's a very basic boilerplate. So in Foundry, tests are written in Solidity. Okay, so just to make it clear, we use Solidity to test Solidity, okay? So in our test file first, since this is a smart contract, we have to define a pragma statement. Then we import some utility from our testing framework. Then we import the smart contract that we want to test. Then we define a smart contract for our test, and we make it inherit from the test smart contract of Foundry. So is test, that means this inherit. And thanks to that, we're gonna have a lot of utilities that we can use for testing here. So we need to define some variable first. So let's define a variable of type prediction market. This will represent our smart contract. We're just gonna call this market to make it easy. And we're gonna define a couple of addresses to represent our different gambler. Okay, we're gonna simulate some gambler. So here to create some addresses, we can use the address operator here, like this. So it's gonna give it a first address, then second address, then a third address, and also what else do we need? We need the Oracle. So the Oracle. Okay, let's make this different addresses here. Okay, so Gambler 2, Gambler 3. Now we're going to define the setup function. So this is a special function that is called before each test. Okay, so this is defined like this. And first we're going to define. We're going to deploy we're going to deploy our function. So market. Oops, here a little problem of alignment. Yeah, right. Now this is better. Yeah, I have OCD for alignment. I want my variable to be perfect. Okay, so here we deploy a new prediction market like this, a new prediction market, and we pass the Oracle in the argument. Okay, and if you remember, in the constructor here, we have one argument. Okay, so here this corresponds to Oracle here, and the market variable here references this variable defined here. Okay. Then we're going to give some ether to our different gamblers so that they can gamble, because we need to send money when we gamble. Okay, and we can do this with the special function deal. So this is provided by the Forge framework. We got it thanks to the inheritance here. So Gambler 1 is gonna get 10 ether. Okay. Same for Gambler 2 and Gambler 3. All right. And so okay, so now we have our deploy. So for each test, we deploy a new prediction market and we give some money to our gambler. So next we're going to run our first test. And how do we design the test of a smart contract? Well, we need to test each function basically. So here we have 3 functions, so we know that we have at least 3 tests, right? Wrong. Actually, we have more than this, because when you test a function, you want to test both the happy path, meaning when everything goes well, but you also want to test the unhappy path, meaning that when something goes wrong. So what if we hit the required statement here? So for the bet function, we have 1 happy path and 1 unhappy path, so we're gonna have 2 tests. For the withdrawal function, we have 1 happy path and 1, 2, 3 unhappy paths. So total here, we're gonna have 4 tests. And for the report function, we have 1 happy path and 2 unhappy one. So total, we're gonna have 3 tests. Okay, so let's start with the happy path of the bet function. So a successful bet, basically. So to create a test, what you do is create a function, you prefix it with test, and then we give it a name, so test bet. Okay, and after that, we are going to tell Foundry that we want to execute this text from the gambler one. Okay, so this is how we do it. So everything that comes after will be, all the transactions sent after will be done from gambler one. Now we're gonna send a transaction to market with market.bet, and so we need to give it some money first. So value, let's give it 1 ether, okay? And after that, let's specify the site. So prediction market. So we can reference this because this is imported here, and we can reference its type. So dot side, and we're going to bet on Kamala, okay? So now that we've done this, we're gonna run some assertion because our function is supposed to update to mapping, and it turns out that I made those mapping public, and when you make a variable public, it's going to create a getter function. So this means that under the hood, Solidity is going to create a function that is called bets per candidate, and the key is here is going to be the side, okay, and it's going to return a uint, okay, and for this one it's going to be slightly more complex. So the getter function that will be created for this one, so bets per gambler, now we have an inner mapping, so we actually have 2 arguments. First one will be address, and second one will be the side, and it's going to return the value, so a uint, okay? So under the hood, Solidity does this when you declare a variable public. And as you can see, this is very useful for testing. So let's take advantage of this, okay? So we had to run an assertion, so we can use the assert equal function provided by the test framework of Foundry. And here we're going to do market.bets per candidate, okay? This is our getter function, and we pass our side, so prediction market.side.Kamala, and this should be equal to 1 ether. Okay, this is what we sent here. But what about that? We also need to test the other mapping for Trump, and we need to make sure that we have 0. Okay, so 0. And what about the bets per gambler? We also need to test that. So assert equal market bets per gambler. Well, actually, we don't need that one because let me see. No, we do need it. Bets per gambler. So first one with the address of the gambler, and second the side of Kamala, okay, and this should be equal to 1 ether. Okay, so let me see. Normally everything seems to be fine. So once you've done a test like this, instead of writing more tests right away, you want to run the test to make sure that everything works fine, because if there's a mistake, you want to correct it as fast as possible. So to run a test, we're going to do forge test, then we reference the test. So prediction, let me see. Oh, sorry, we need to get inside the blockchain, inside a Foundry project. So forge test, and then prediction market.t.sol. Okay, actually we forgot one flag here, so it needs to be match path. Okay, let me see. Yeah, this is all we need. Okay, so let's press enter, compile, and this is working. Amazing. Okay, so here it shows you the function that was tested, how much gas was spent. Okay, 1, so it means that it passed. And here I also want to show you what does it look like if we have a failing test. Okay, so let's say here 2 ether, so this is gonna be wrong. Okay, so let's clean this up. Let's run this, and now we have a fail. Okay, reason assertion fail. So we were on one side we have 1 ether, and on the other side we have 2 ether. And if you're wondering why we see this huge number instead of just 1 ether, that's because under the hood an ether is actually represented in a very small unit called a way, and one way equal 10 power 18 10 power minus 18 ether, or in the other direction 1 ether equal 10 power 18 way. Okay, so here basically you will see 18 0. And so here you can see why you have this, and it's also possible to make your test more verbose with a -v, and there are up to 3 level of V. This is V for verbosity. So here you press enter, and why it's, oh yes, so here you can see basically what's called the trace. So it's going to show you in more detail all the code that it did with the return value, etc. So if you are struggling to understand why you failed the test, this is very useful. Just add 3v to your command. Okay, and here actually we're going to do something very useful, because we're going to run this test over and over. And so it can be a good idea to create what's called a makefile here. Okay, so here you create a makefile, and we define a test command, forge test, and here we copy pasted our command here. Funny test, this is to basically some makefile stuff. So all the command that you're going to use, you need to add them in funny like this. And then to run this test like this, let me show you how does it work. Now you just need to do make test. Okay, and now it's failing. Okay, so let's fix it. 1 ether, sorry. Make test. Okay, so now this is passing. Very good. So now we need to test the unhappy path. Okay, so let's do this function test. Let me see. Test bet election finished. Public. And so we're gonna prank with a gambler. Let me see. Okay, so first of all, we're gonna prank with the oracle, because only the oracle can finish the election. So it's going to be market dot report. So prediction market. Let's pick a side here. For example, Kamala. So Kamala won. Okay, and this is the winner, and the loser will be Trump. Okay, so report this, and after that we're going to try to bet with the gambler. So now we prank from the gambler to change the sending address, and we're going to expect an error, and so for that we use this another assertion called expect revert, and we need to give it this error string. So election is finished. All right, and after let's send our bet. Okay, so actually let's copy paste what we have above. Okay, so here we try to bet on Kamala, but we're gonna have this error. Okay, so let's run our test, make test, right? And now our test is passing. Okay, and it may seem weird, because actually an error happened, but we specify in our test that we're expecting an error. So if the error doesn't happen, the test will fail. Okay, so now we've tested the happy pass and the unhappy pass of this function. So next we need to test the function when the election. Let me see. Let me see. Next we need to test the withdraw function. Okay, so withdraw. And let's make it public. Okay, so first of all, we're going to place bet. Okay, so let's print this gambler 1 and let's vote for Kamala, for example. Right. Next, we're gonna vote with gambler 2. So we vote for Trump this time. Then let's do who? Gambler 3. So this is gonna be Trump again, and let's do 2 ether for each. Okay, then Oracle reports the result. Okay, so we can do another copy paste here. And this time, let's change. This time it's gonna be Trump. Trump win, Kamala lose. Because otherwise, if I always make Kamala win, you know, you're gonna accuse me of being Democrat or whatever. So I'm not American, so I don't care. And so here we, okay, VM print Oracle, then we report this. Okay. And then after that, the gambler 2 is going to withdraw. Gambler 2, withdraw. Yeah. So gambler 2 withdraw, but first we need to get its balance before. Initial balance, gambler 2 balance. So you can read the balance of any address like this on the address object. Then let's print with gambler 2 and market withdraw. All right, now same thing with gambler 3. Initial balance 2, initial balance 3. Okay, and now let me see. And finally, we are going to verify the withdrawal. Okay. So we want to make sure that they actually got their money. And for that, we do assert equal. So gambler 2 balance, and it should have initial balance 2 plus 3 ether. So why 3 ether? Okay, so let's go back to here where we actually placed the bet. So total, okay, so Trump won here. Okay, so that means that the pot of the loser was only 2 ether because only one person voted for Kamala. So these 2 ether is going to be shared proportionally to those 2 gamblers, but they bet the same amount, 2 ether each. Okay, so each is going to receive 50% of the pot of the loser. So they're going to get back their initial 2 ether plus 1 ether coming from here. So this is why here we are expecting 3 ether more. And the same thing is true for the other gambler. Okay, so other gambler here. And all right. Now we also need another assertion. We need to make sure that the bets per gambler of gambler 2 prediction market side Trump. So this should have been reset to 0. Okay. And same thing for the gambler 3. Okay. Yes. All right, guys, so we have everything for this test. Okay, so let's run the test again. And this is working. Amazing. Okay. Oh, no, sorry. Okay, big. Okay, here, guys, this is a typical mistake that almost done. I thought I run the test, but look carefully. Okay, 2, we just run 2 tests. Why we did not run this test? Because I forgot the prefix test. Okay, so it will only run the test that start with test. Okay, so we have to be careful, because otherwise you think your test passed, but actually no. So let's run it again, and now we can see okay 3, we can see test withdraw. Okay, fantastic, we are making progress. Let me see any question here. So Keezer is asking, will you make bet and withdrawal function non-reentrable? Okay, so this is a little bit outside the scope of these tutorials. We still have quite a few things to do, but very briefly, there is a very specific type of smart contract hack that is called reentrancy, where a function is called in a loop several times, and you can basically drain the code of a smart contract. But one way you can protect, there are different ways you can protect against this, but one way you can protect it is by doing the state update before you send money or call a function on another contract. So here we change the state, and only after we call another, we do the transfer. So even if there was a reentrancy vulnerability, because of that, they wouldn't be able to exploit it. But let's stay focused, because we still have a lot of work to do. Okay, so next we need to test the unhappy pass of the withdrawal function. So what about if we try to withdraw? If we lose, we are a loser, and we still try to get some money. Okay, so no winning bet. So in this case, we should lose, right? We shouldn't get our money back. So first of all, we're gonna place our bets. Let me see if we can copy some code here. Okay, so gambler, let me see. Gambler 1 and 2 are going to withdraw, bet 1 Ether each. Okay, Oracle is going to report the result. All right, and now gambler 1 tries to withdraw. Okay, so Trump won, but gambler 1 betted on Kamala, is still trying to get some money back. Okay, so VM prank gambler 1. Okay, VM expect revert. You do not have any winning bet. Okay, so this is the error message that you see here. You do not have any winning bet. Okay, and finally, let's call withdraw. All right, so now let's run the test. And this is working. So here, test withdraw non-winning bets. Okay, 4. Fantastic. You guys still with me? Yes, amazing. Hey, today we have a lot of people on this stream, so this is amazing, guys. Very, very good. All right, so next, we're gonna test the withdraw function, but another unhappy pass. So if the election is not finished, okay, so first we are going to place our bet as usual. Okay, then gambler 1 is going to try to withdraw, but the election is not finished yet. And the error message here is election not finished yet. Okay, let's run this. And this is working, so we can see our test here. Okay, 5. And I just want to show you if the reason doesn't match the reason of the record statement that you provided. So here there's a typo. We are missing a T, for example, but here we can see there is a T at the end, so there is a mismatch between those two strings. If we try to run this test, what you will see is it's going to fail, because even though there was an error, the error message was different than the one expected. Okay, so let's fix this like this, make test, and yeah, this is working. Okay, amazing. So next we're gonna test the report function. All right, so first of all, so this is the happy pass, okay, if everything is going well. So market report, so prediction, market side, and who is it going to be? Side, Kamala. Prediction side, Trump. Okay, so Kamala is going to win. Assert equals, so market dot election finished. This is true. So the election finished variable boolean value should be equal to true. Then what about the winner? Okay, so can we do result? What about if we do market.result.winner? So in the result struct, we want to access the winner variable, and this should be equal to 0. Okay, so why is this? Because let me explain. The side, actually, there's an equivalence between an enum and a uint. So Kamala here, if you try to convert a uint to a side, 0 is going to match Kamala, 1 is going to match Trump, etc. Okay, so here Kamala is the first option, so this is index 0. Okay, and now for the loser should be equal to Trump. Okay, but if you do this, this is not going to work. Solidity didn't like this. Okay, so in order to fix this, what I did is that I read the result variable like this. You can do it because this is a public function, and it's going to return this struct. But what it's going to do, we cannot read this struct directly. However, we can destructure its field. I'm going to show you how to do this. So in order to read this, what you do is prediction market dot side. It's going to be the winner, and then for the other one, this is going to be the loser. Okay, so if you know JavaScript, it's a little bit similar to, for example, when you do something like this. You can destructure an object like this. Okay, so a bit similar. Okay, so now we can reference the winner directly. And if you do this, If you do this, actually it doesn't work, because here this is the type of the variable is side is not a uint. So what you could do is you could cast this into a uint like this. Okay, the same with Trump. Let's see. Oh, sorry, winner, loser. Okay, and so this is working. Amazing. Next, we need to test the unhappy pass. Okay, so function test report by non-oracle. All right, so we're gonna run a prank by the first gambler. Expect revert only oracle. That's the error message. Market report. And let's try to report, for example, that yeah, this doesn't matter. What matters is that we're trying to do it from the wrong account, from the gambler. Okay, so let's try to run the test. And this is working. Okay, now we're gonna run the test the other unhappy pass, which is the invalid result. Meaning when the winner, so the sender will be the oracle, no problem with this, but both of them are the same side. Okay, this shouldn't be allowed. And here the error message is winner and loser cannot be the same. Okay, and so now our test suite is complete. Everything, all our tests pass, and we test all the function, the happy pass and the unhappy pass. Okay, so this is very good. Next, we need to work on our deployment script. Okay, so, and this is going to be in the script folder. All right, so let me clean this up. All right. So what is this? This is a script that we're going to use for the deployment on a blockchain. So first of all, we import our prediction market, then we define a smart contract for the script. So similarly to the test, the deployment script, they are also in Solidity. So in other words, we use Solidity to deploy Solidity. So here we have the setup function. Let me see. Yeah, the setup function. So this is a function I actually never use in Foundry script. I always use run. So let's focus on that. Okay, so we need to do different things. First, we need to deploy the prediction market. Then we're going to seed the market. So because in the front end, when we launch our app, we want some demo data. So we want to simulate some gambler. Okay, so simulate gambler 1, simulate gambler 2, and yeah, we're gonna simulate 3 gambler. Okay, so first of all, we need to define the private key of these different addresses. Okay, so first of all, so the private key, you can represent them with the uint. First of all, we want the private key of the deployer. And how are we going to do that? I'm going to show you this. So we're going to launch a local blockchain called Envol. So Envol was installed when you install Foundry before. Okay, so when you do the Foundry installation, it installs different things. One of them is an executable called Envol that can run a local development blockchain on your laptop, and this is what we're going to use to to build the front end. Okay, so here let's press enter and we see a couple of details. So envol, and it gives you a list of accounts that are available. So keep in mind, this is a blockchain only on your laptop, completely isolated from the real mainnet network of Ethereum. So you can do any mistake, it just doesn't matter. Here we have 10 accounts with the different addresses. Each of them comes pre-funded with 10,000 Ether. This is some fake Ether, of course. And you also have the private key associated to all of these accounts. So we're going to use those private key for our deployment script. So the first one, the deployer, I'm going to use the last private key here. Right. Then for the gambler, let me see. I'm going to use the second one. The first one, I'm going to keep it for the front end. Okay. This is going to be ourselves, the first one. So here, let's define the gambler 1, gambler 2. Let's choose the third address here. What about gambler 3? Let's use this one. All right, so now let's deploy our prediction market. So we're gonna run a command called start broadcast. This allows you to tell which address to use for the deployment. So here you need to pass the private key here. So we pass the private key of the deployer, and let's deploy a new prediction market. And we need to pass the address of the oracle. So which one we're going to use for the oracle? Let's choose the same address as for the deployer. But here, we're actually expecting an address, not a private key. So how can you convert a private key to an address? Well, you can do this with vm.addr. This is provided by Foundry. You pass the private key like this. And let's get this into a variable. So we define here a variable market of type prediction market. So now this variable represents our prediction market. And after we're gonna do stop broadcast. So why stop broadcast? Because when we're gonna run this other transaction, this is gonna be from a different private key. Okay, so we need to encapsulate our call like this. Okay, so now let's simulate the gambler 1. So now let's pass gambler 1. Okay. And now we're going to do market.bet, and let's pass some, let's say we gamble 10 Ether. Okay. And the side's going to be so prediction market dot side dot Kamala, and then stop broadcast. Okay, now we're going to do another bet with gambler 2, 10 Ether. This is going to be on Kamala as well. Okay, and now what about gambler 3? Gambler 3, and this time this is going to be on Trump. All right. And now it should be complete for our script. So now what we're gonna do is let's run this script. So I'm gonna show you what I have in my Makefile. Deploy here. So forge script. This is how you run script. Then you pass the name, the path to the script, then colon, and finally the name of the script. So this is called deploy script. Let me show you exactly where it is. Here, this corresponds to this. And then broadcast, so it means that you don't want to just simulate this script, but you want to actually send the transaction for real. Otherwise, it just does a simulation. And finally, RPC URL. So you specify which blockchain where you want to send this transaction. And so this is the URL to our local blockchain. This is Envol. And how do I know this? Well, that's because when we run Envol, it will tell you what here is URL. So you can see it here. Okay. So let's run deploy. Okay. So make deploy. No rule to make target deploy. Let me see. Okay, let me try to remove it, because before I didn't have it and it was working. Okay, no. Fair enough. I am in the wrong folder. Okay, so blockchain, make deploy. Okay, so on-chain execution complete and successful. Very good. So let's see the different transaction here. So here we have first transaction. It tells you the contract address 0x700 something for the first block. It tells you how much gas it costs you. Then second one was the first bet. Okay, block 2, block 3, another gambler, and here another gambler. And yeah, so everything works fine. And you can actually see in the output of Envol, you can see also those transactions. So here you can see the last one, third one, second one, and the first one. You can see contract created, and this matches the information we get on the other prompt. Okay, so everything worked fine. Great. Now there's another script that I want to create, and this is a script when to simulate the report. Okay, so once the election is over, it's going to simulate the oracle that's going to call the contract. Okay, so here prediction, let's define the address of the prediction market. So prediction market address, and we have the address here. Okay, it's this one. Right, then let's define a variable for our market, prediction market, and let's give it the address. So here I want to point out something very important. Here we just define a pointer to an existing smart contract, but there isn't the new keyword. Here you can see the new keyword, so it means deploy a new contract. Here it doesn't mean deploy a new contract. It means this contract already exists. I just want to interact with it. Okay, and let's define the address of the deployer. So yes, it's just going to be the same as before. Right. Function. I'm not actually sure if we require the setup function in a script, but I think so. And then we have the run function. So this is where the action is going to take place, the start broadcast. We're going to do this from our deployer here. Then market report and who wins, prediction market side Trump, prediction market side Kamala. Okay, and finally stop broadcast. All right, so now we have our report script, so we're gonna run it. So in the make file, we already have a command ready, forge script, same path, but this time we target another script and the rest is the same. Okay, so let's execute this, make report. All right, and okay, so here Foundry is pretty sensitive. It wants what's called a checksum address. So this has to do with this is a way to verify. This is a mechanism to check that an address is correct. And some development tools don't care about this, but some do. So here it just gives us the solution. So let's replace this address by the what's called the checksum version. Okay. And with this, we should be good. Okay, so make report. And now this is successful. Okay, we can see the transaction hash here. And the execution, the report function worked. Amazing. Okay, so let's recap what we've done so far. We have created the prediction market smart contract. We have tested the function of our contract here, the happy pass and the unhappy pass. And finally, we've created two scripts, one for deployment where we deploy the contract and then we simulate some gambler. And finally, a script to report, to simulate a call to the report function. Okay, so now we are going to do the front end. All right, are you guys still here in the chat? And where you guys are from, let me know in the chat, all right? Let's take a quick water pause here, water break. Where you guys are from, let me know. Okay, so as I said, next part is the front end. So we're gonna leverage what we did so far. Okay, so back to the code. So now let's close the blockchain folder. Let's open SRC app. This is where we have the front end, and page is, this is our home component. Okay, and one of the first thing that we need to do is connect to MetaMask. Okay, so if you haven't MetaMask installed, you need to install it. Basically, that's a MetaMask allow you to this is a wallet that you need to build blockchain app, and technically this is a Chrome extension, so you can install it with the Chrome store, and then you're gonna see this little fox appearing. Okay, and then you can add some accounts. Okay, so here what I've done is I've added the account of Foundry, and you can do this here by clicking on select an account, and here what you can do is add account or hardware wallet, and here you do an import account, enter the private key, and here you're going to copy paste what you get from Foundry, from Anvil. So let me scroll up. Oops, is it the right? Let me see. Is it the right thing? Yeah, it's the right. So here we're going to use the first address, and you use this private key here. So you copy paste this into MetaMask. So here, add account, import account, and you paste it here. You click on import, and after you're going to see the address here in your list of accounts. So I've already done it. I can see it here, 0xF39. Okay. And the second thing you need to do is to define a new network. Okay, so because here you can select the different network to connect to, and we want to connect to a local development blockchain. So you click on add network, add a network manually here, and so you give it a name. So local network. Here the RPC URL. So this is going to be. Let me see. This is going to be this one. So needs to be HTTP. Okay, so HTTP : chain ID, so you can see it just above. Chain ID is this one. Then currency symbol, you can put ETH, and then you click on save. In my case, I've actually already configured that, so I'm not going to do it again. Okay, but this is what you need to do for a new installation of MetaMask. Yeah, so here local network 85. Oh, I forgot 80. Let me see. Yeah. Colon 8545. Okay. And there's the last thing that you need to do, and this one many people don't know it, and hey, you will pull your hair for hours if I don't tell you this. So pay attention. Okay, so you go after you start a new Envol session, you go here in settings. Okay, so the dot here, settings, advanced, and here you're gonna click on clear activity tab data, and it's going to reset the account nonce. So nonce, this is an integer that is incremented after each transaction, and your wallet keep track of it, no problem. But when you use Envol or any local blockchain that you restart, then MetaMask get confused, and after each restart, you need to reset the nonce as well. Okay, so here you click on clear activity tab. Make sure you are on the right network and you are selected for the correct address. Okay, don't do this on the real mainnet address. So here, clear. All right, and after that, you've set up MetaMask. Congratulations. All right, so let's go back to our code, and so now we need to connect to MetaMask. So we need to create a button that connect to MetaMask, because by default MetaMask doesn't allow you to access it. Okay, the user needs to allow you. So I've created a folder in src/app called components, and a subfolder connect. Okay, and inside I define a new component with in index.js. Okay, so what we're gonna do here is a couple of things. So let me see. We need to have a button. Okay, so a button connect to MetaMask, and so when people click on this button, they're gonna show a pop-up. They're gonna see a pop-up. They're going to accept it, and then once they accept it, they will basically we will connect to MetaMask. Okay, so here let me define a function on click event handler. Okay, and we're gonna call a function called connect wallet. So let's define this. All right, yeah, let's give it a class name. All right, now what we want to do in this function is so if first of all we want to detect if we have MetaMask or not. Okay, install. So if we have MetaMask, this object is going to be populated window.ethereum. Okay, so if this is equal to the type of this is equal to undefined, then what we're going to do is we're going to set an error. Okay, so first we need to define an error state. And first this is the empty string. Okay, and here let's import this from React. use state. Right. So here the error is going to be MetaMask is not installed. Please install it to connect your wallet. To use this app, sorry, it's better. Okay, and then we're going to return. That's the end of this function, okay? Otherwise, what we're gonna do is let's try to connect to MetaMask, and we wrap everything in try catch because it's possible that we have some error. If there is an error, let's log it, and then let's do connection failed. Please try again. All right. Then we're going to initialize what's called a provider. So initialize either provider and signer. So provider and signer, these are two different objects that allow you to communicate with the blockchain through MetaMask. So provider, this is pretty much a read-only object, okay? And signer, this is when you want to send transaction, when you want to modify the blockchain. So the first step is to get the provider. And for that, you use Ether. So we actually need to import Ether. Like this. Okay, ethers dot get browser provider in window.ethereum. So this is going to connect to MetaMask by using the ethers library. And once we have the provider, we can get the signer. Okay, step 1, get provider. Step 2, get the signer. All right, let's make it async. So because we use await. All right, now let's get the address of our wallet, and we can get it with our signer. So when you call this function, the user is going to see a pop-up that asks it, hey, do you want to connect to this app? Okay, and if they accept, this is fine. Otherwise, if they refuse, we're going to end up here. And next, we need to create a contract object. So a contract object allows you to interact with a smart contract. So we need to interact with our prediction market. So for that, let's use the contract object of ethers. And we need to define different things, the address, the ABI, and finally the signer. So we've already defined it. So what about the address of the prediction market? Well, it turns out I've created a file, blockchain.json, to give us all the info. So first, prediction market address, I've copy pasted the address that we got from Foundry when we did the deployment. And then I also created something else called an ABI. So this is an array that tells you what is the function signature of our smart contract. And with this, we can interact with a contract. And to get that, all you have to do is you go, okay, let's close here the test. Let's close the script. And all you have to do is you copy paste each function signature here, and you paste it here. There is a caveat, okay? The caveat is for bets per candidate. So actually it's not defined explicitly because this is a public variable. So as I explained before, when you declare variable public in Solidity, it creates a getter function of the same name, okay? So you have to to write the function signature yourself, but it's not too difficult. And here, this function takes as an argument the side. So this is a custom type that we define in our contract. But here, if you put side, our custom type, it's not going to work. It's custom type don't work in ABI. But a side, I told you there is an equivalence between an enum and a uint. And each option in an enum is equivalent to a uint 8, okay? And view means this is a function that you can execute in a read-only mode. So contrary to this one, for example, where if there is not the view keyword or not the pure keyword, it means this is a normal function that we execute in a transaction. This one transaction, this one transaction, this one view function. And in the view function, you also have to define the return type. Same thing for the other one, okay? Okay, so we have our ABI. Let's go back to our component. So now we're gonna import that blockchain from blockchain.json, and now blockchain.address. Sorry, it's not a prediction market address. The other one is blockchain prediction market ABI. Okay. Now we're going to need to fetch the network. So we want to provide some feedback to the user. Okay. So let's get the network from MetaMask. Get network. This is going to be an object with different information about the network we connected to. Then set state. So I'm going to save different variable in our state. So set wallet address. Let's define this. So set wallet address. Different things we need to define. The network. What else we need? We need to know if we are connected or not. So originally we are not connected. And last thing, we want to know if this is, let me see. We also need a success variable. All right, let's go back here. So we saved the wallet address. How about the network? Okay, so we want two things from the network. We want the name of the network, and we also want to display an image. So what we get from MetaMask is not enough. Okay, so we're gonna get a network ID. So that's a number that identifies a network, but we want something a little bit more user-friendly. Okay, so we're going to build a dictionary basically for each network, and the key will be the network ID. So here this is a test net, so the network ID is 31337, and this is Foundry that gives you this number. And here we know that the name of this is Ethereum local network. And for the logo, so we're even going to do a logo eth dot, let me see, eth dot png. Okay. And what I've done is, so in the public folder of your Next.js project, you can have images. Okay, so I've created a folder called logo, and inside I've put ETH PNG, and here you can put the logo of the different network that you want to connect to. Okay, and now what we can do is we use this dictionary. I'm going to save this in the state, so network info, and here let's read network chain IDs. This is what we get from MetaMask, and we convert this to a string so that we can select. It can be the same as our key in our dictionary. Okay, so set network, set is connected to true, and set success, so wallet connected successfully. And finally, we need to pass the signer in a contract to parent. So this component is going to be rendered inside our home component, but we need to, the home component is going to use the signer. Okay, so we're going to pass this like this: set signer, set prediction market. All right, and we need to accept this as argument, so it's going to pass as a prop. So set signer, set prediction market. All right, so now what about the HTML? So first of all, this button, we're only going to render it if we are not connected yet. Okay, so if we're not connected, let's render it. All right, and now what about the rest? So the rest, we are going to, if we have a success, okay, or if we have an error, we're going to define something else. So if we have success or error, let's render all of this. So I already defined a style here. All right. Then what else we need to do? So if we have a success, okay, so this is a little bit boring, so I'm just going to cheat a little bit. Just pardon me, but sometime, you know, we need to go a little bit faster. So here, if we have connected successfully, basically we're going to show a success message. Here I'm going to show an icon of success, and here was a success message. Otherwise we show the error message. So this is really standard stuff. And all up below that, if we are connected, and we already have some network information, I'm going to show something else. So let's give it some styles that we'd already defined. And we're going to show an image. Okay, so I'm going to show an image of Ethereum, I mean of the network that is connected. And so this is going to be the logo folder, and then network dot logo. Okay, width, we need to give it a width and a height. And the alternative, the alt text, so network dot name. Okay, and let's close this image of object, a component. We need to import it also, so this is something we can get from Next.js. Okay, so import image from next image. Okay, let's go down. After that, what we're gonna do is we need to show the name of the network. So network name, okay. And below that, we're going to show the address. Okay, so and here the wallet address. All right, so I think we are good for this component. We need to make sure we pass these two things, set signer and set market. So now let's define this state here. So first of all, let's import use state from React. Then set signer. All right, same thing for the prediction market. All right, let's import also the component. So connect components connect. And now just below this, we're gonna have the connect component. So we pass those two as prop set signer and set prediction market. All right, so let me see if everything compiles. No, we have a little problem here. Okay, so here we're problem of pass. Let's go back to our component here. So this is the wrong pass. Okay, this is 2 levels above. Let me see. Now we have another problem. We did not import the styles. So let's do that. Let's import our CSS. Okay, so now it seems to be okay. So let's go localhost, see what we get. All right, so bet on the US election, connect to MetaMask. Let's see the console here. Connect to MetaMask. Signer address is not a function. All right, so where did we make a mistake? Oh yeah, here it's not address, it's get address. All right, so let's reload, connect to MetaMask. What address is not defined? Really? 74, we haven't defined this state. It's weird. Here, okay, typo. Should be called wallet address, not just wallet. Okay, back here, connect to MetaMask. Hey, why? So it's weird. So we have a success and a failure. Type error. Set signer is not a function. What is this? Why? Okay, so it seems that I thought I defined set signer here. This is weird. What happened? set prediction. Let me see. Set signer, set prediction market. Yeah, okay, I define them in the prop, so it should be fine now. Index.47. Let me see. What is the problem? So set signer and set prediction market, I give them here as prop and I also give them here as prop. So why is it not happy? Is it a typo? Am I crazy or what? Connect set signer. Okay, this is defined here. Set prediction market in set signer, set prediction market. Yeah, it's correct. It's completely correct. So why is it not connect wallet index 44? That is really weird. Why is it doing this? I hate when they do this, where there's something that I don't see. It's just right in front of my eyes. But set signer, okay? Here, set signer. Maybe I didn't save it. No. Okay, save this. Save this. And reload. Set signer is not a function. So what is it? I'm asking, what is it? Just console log. What is set signer? Good old console log to debug, as always. Here. Here, this is undefined. Here, undefined. What about outside the function? Is it undefined as well? What about here? Okay, so now I can see it. Oh, guys. Okay. I'm so stupid. It's entirely my fault. Right in front of my eyes. Okay. So basically, I destructured. I put this at the wrong place. Shouldn't be here at all. Yeah. So I was like shadowing the prop that is defined before. Okay, so stupid. But I saw it. It's fine. So now, finally, no errors. Wallet connected successfully. Ethereum local network. We can see the logo, and we can see our address 0xF39. So here, let's check 0xF39, which is the address of Foundry. Okay. Very, very good. So next, what we need to do is we have this connect component. Next, we need to show the pie. Okay, I'm gonna show you. Oops. Yeah, we need to show this pie. So we're gonna use React, this library called React Chart.js. Okay, so I'm gonna show you what it is. Yeah, React Chart.js 2, and so this allows you to do chart very, very easily. Okay, so in order to do that, we need to define a new state first. We need to define the new state is going to be bet predictions. So this is going to read from the smart contract set bet prediction. So now let's also define a use effect function. So basically we need to wait to have the prediction market ready, and when we have the prediction market, then we can call our smart contract. So use effect and here let's wait for the prediction market to be ready. So everything's gonna be wrapped in a init function inside. And when if prediction market init. So every time this changes value, what is inside will be executed. And if this is not undefined, then we call init. And now what we need to do is call prediction market dot bets per candidate. Okay, and so for Kamala it's going to be 0, and for Trump it's going to be 1. But you know, it's not really nice to see 0 and 1. We don't really know what does it correspond to. So let's define a constant here. So Kamala 0, Trump is 1. Okay, and we're gonna call this together with promise.all. Like this. Okay, by the way, let's use the variable we just created. So Kamala in Trump, and let's get this bets like this. Okay, and we can console log already what we see. Bets. All right, so let's reload, connect to MetaMask, and let's see here, and we see an array, okay, with two entry. So the first one, we see that there was, is it 2 Ether or 20 Ether? I don't remember. Let's see the script that we created before. So, okay, so we have 10 Ether on, we have 20 Ether on Kamala and 10 on Trump. So here you can see the 20 Ether on Kamala, okay, index 0, and then the one of Trump is 10 Ether, the second one. All right, so back to our component. Let me see, where is it? Here, page. And the next thing we need to do is to create an object for the React library that we, for the charting library we're going to use, and it needs a specific shape. Okay, so let's create the object that is required. So first we need some labels. So the two labels will be Trump and Kamala. Okay, and what else do we need? Then we need a data sets. All right, so in the data sets, first let's define the data. So the first one is Trump, so bets1, and we're gonna transform this to string, because by default all the number that you get from the blockchain, this is a special JavaScript number called big int. It's a special type. So we want to convert this to string, because otherwise the library, the charting library, is not going to be happy. And the other one is the first element of the array, same thing, to string. Okay. Then here is actually an object, sorry. So, and we only have one data set, but you can have several. Background color. Okay, so this I'm just going to do some copy paste, nothing interesting here. So you can choose whatever color you want just to make it nice. Okay, so now we have our object. What else do we need? So yeah, so I think that's it for the bet prediction. We only need this, so bet prediction. And after that, let's import what we need from the charting library. Okay, so import pi from React chart JS2, and there's a little thing that I needed to fix, so because it wasn't working when I tried this, so there's a fix that I found on Stack Overflow. You need to do this: import chart.js/auto. Don't ask me why. I'm not an expert in the React chart.js, but I just know it works. Okay, so yeah, this is what we need. Okay, so after, let's use this library. Okay, so let's go down below connect. And if we have bet prediction, then we can show the chart. Okay, so here I just use some bootstrap class, current odds. Bet prediction. Okay, so here we use the chart library, and we give it as a prop the bet predictions are from the smart contract. Okay, so now let's see what we have in the front end. Connect to MetaMask, and fantastic, look at that. So we see the 10 ether of Trump, and we see the 20 ether on Kamala. Okay, so this is working fantastic. The next thing that we need to do, so let me see here, this is the end result. Okay, so next we need two forms to be able to bet on Trump or Kamala. Okay, so let's do that just below our chart. So you know what, there is a lot of HTML here, so I'm just going to spare you because it's just not the most interesting. Okay, so let me spare you this. So let me make sure that I copy everything. All right, let's place bet. Okay, so I'm gonna explain everything. So here we just use some bootstrap element, a card. So this is a bootstrap element that make it nice. And I'm going to use the image of Trump that I have already put in the public folders or public IMG. I put the image of Kamala and Trump. And so we have a form here, okay, where we have two inputs. I mean, one text input, sorry, and a button. The text input this is where you put the amount of Ether that you want to bet. And when you click on the buttons, it's going to trigger this on submit. It's going to trigger a function called place bet for the side of Trump. And for Kamala, this is, let me see. Yeah, so for Kamala, this is the same thing, except that, okay, we need to do the other side, form inline, yeah. So side Kamala. All right, and so now let me see what we, so first of all, let's define the place bet function. So now we can see this Trump and Kamala, fantastic. And now we need to create this function, implement it. So first of all, prevent default to prevent the reloading of the page. And now what we need to do is transaction response, prediction market in bet, so side, and then for the value, so this is another argument, e target elements. This is the first element of the form, and we want the value. Okay. And then we need to wait for this to be mined. Okay, so here, transaction receipt. Let me see. Does it look right to you guys? Looks right to me. Right, so connect to MetaMask. I want to place, I don't know, just let's say 10 Ether, okay, on Trump. 10 Ether, but then I need, it's 10 power 18, okay? So 10, I need 18, 0. 1, 2, 3, 5, 6, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So of course it's not really user friendly, and it's better here to just enter an Ether value and to do the conversion after, but I didn't have time to do it, so just gonna do it this way. And here if we click on submit, we're gonna see the pop-up of MetaMask. Okay, so click on submit. Okay, whatever. Let's try 10 here. Why? Error in promise. What's the problem here? Okay, let's do a try catch because we have a problem. I don't know what it is. Okay, I think this is I think this is reloading the page. Look at that. I'm pretty sure this is reloading the page. Yeah. Okay, so we have a problem of reload. Why this is doing this? This is not what we want. Okay, so side Trump on submit, and then place bet. Oh, okay, I'm missing the T here. Prevent default. Okay, my fault. So let's do it again. Cannot read property. Okay, I think we don't care about this, but so no data present. Okay, so let's console log what we get. Console log side, because maybe there's a problem with side here. So okay, let me see. Okay, maybe it doesn't. We need to transform this to an integer. I think that's the issue. So let's do parse int. I think that's the problem. No. Sorry, we need to transform this to a string. It's already an integer. Side to string. Do we have this function on JavaScript number? I think so. 10. Let me see. 2. Type of. Just want to make sure we do have a string. So yeah, this is a string, but it's still not happy. So bet. Okay, let's try to read. Maybe. Okay. I think this one also is not a string. So let's clean this up. It's getting messy. Okay, so 10. Yeah, this is not a string, right? Oh, this is a string. Okay, so no, so the value is correct. Prediction market. It's not a string. Let me see. Why is it not happy to like this? Let me see if we at least do we get some do we see anything on Envol? No. Execution reverted, likely require false occur. Okay, you know what? Let's keep going. I don't know what's causing the mistake here. Maybe it has to do with the fact that we accept the function accept an enum, and so it's possible that there is a spatial way to format the argument here and not do it as a string or as a number, but pretty sure the problem comes from here. Okay. Anyway, let's make some progress. Let's not get stuck. So after, we need to get the bets and finally be able to claim your gains. Okay, so first, your bet. Let's see this. So all right, so I'm gonna do some copy pasting to show you your bets. So we're gonna define a variable that show you your bet, okay? And if we have something, then you're gonna show you your bet like this, in way, okay? So I'm gonna show you your bet for Kamala and for Trump's. So now let's create this state. And we can also do it in this use effect function. So how are we going to do that? Prediction market dot bets per gambler, and we need to give it the address of the site of basically the current address for the two sides. So they're going to be one side for Trump and one side for Kamala. Yeah, so promise dot all, so like we did before. So those two function call will be done at the same time. And here for the signer address, so we need to get it. So we can get it with signer get address. And since we use this object, we need to wait for it to be available. And so here, let's add it to our condition. If we have prediction market and signer, we want both, okay? And with this, let me see. Okay, so here you can see your bets. Very good. And finally, there's this last part that we need. So claim your gains, if any, after the election. So for that, I'm going to do a last copy paste. Yeah, it's just below that. Okay. Right, so what did I do here? So claim your gain, if any, after the election. So we have a button that is going to call a function withdraw gain. And this is going to be just below that. Withdraw gain. All right, and so let's do a try catch as usual. And so prediction market dot withdraw. Right. And then transaction response, let's wait for it to be mine. Okay, and then I can console log this, and ideally we want to show some feedback, okay, some visual feedback to the user like we did for the connect component, but I didn't get that far. Okay, so yeah, Withdrawal, we don't need to provide any argument, and so this one is a little bit more simple. Let's see in the front end, reload. All right, and so now we have everything, all the elements. I wish I could show you a complete demo where we actually click on submit, and it does a we complete the whole cycle. So we do a bet with Trump, and then you can see here this reflected in your bets. And then after, what we can do is we use the script that I've created before to report the result of the election, and then we'll be able to submit. Click here, and finally we can see the Ether going into our balance. But because we have this little problem here with the the execution of the bet function is posing problem. I think that's because of the type of the argument that we provide, but I need to do more research about this. But otherwise all the rest works. And the most important was the smart contract part, and smart contract is working. Okay, so thanks everybody for following up to here. And last thing, if you are new here, don't forget to get your free roadmap for a new blockchain developer. eattheblocks.com/roadmap. This is a complete career guide that is going to be very useful. Okay, thanks for following everybody, and I will see you the next time. Have a great week. Bye.